Good evening, everybody. Welcome to the main meeting of the Triangle Area SQL Server User Group, October edition. So tonight we have a great presenter just waiting to get started. But before we can do that, I've got one thing that I have to talk about, and that is TriPass board elections. They are coming up. Voting is November 19th through December 3rd. Before then, if you wish to run for a position, we have 3 positions open. Nominations are open until November 10th, so there's still plenty of time to get in there if you want to be president, vice president of marketing, or treasurer. Those are the 3 positions that are currently up for re-election. Let me know if you're interested in running for any of those. Current holders, I'm the president. Rick Pack is the vice president of marketing, and Mala Mahadevan is the treasurer. We're all rerunning for re-election, but if you're interested in running, send me an email or hit me up on Meetup. And with that promotion out of the way, I'm going to switch over here to Mohammad, who's going to talk to us all about big data clusters tonight.
Thank you, Kevin. I do appreciate you and the team inviting me to speak about big data clusters. As you see on the screen there, mohammaddarab.com/BDC or big data clusters, you'll find everything I'm talking about in terms of videos, blog posts, and things like that at that link. And that's the QR code for there. I want to make this as relaxing for the attendees and for the viewers, so they don't have to, take notes, whatever. They can just go there and download it right after. The topic, again, big data clusters for the absolute beginners. So if you aren't familiar with a lot of the concepts and the underlying technology that makes big data clusters work, don't worry about it. We'll talk about all of that stuff during this session. The abstract. So if you are a DBA, I'm just a regular old SQL Server DBA, and you feel, or a data professional, and you feel like your skills are becoming slowly blown with the wind or irrelevant in some cases because there's so much new technology coming out. You can just focus on, for example, Azure or the cloud, and there's so many different services and features coming out that someone who's been working in the traditional on-premise in database environment can feel overwhelmed. And this was my case a few years ago. And that's why I created this session. So in case you are that individual, then hopefully by the end of this session, you will feel fired up and ready to pursue a path that will make you relevant again with cutting edge technology. So let's get started. A little bit about myself. 20 years working with IT, a little over 20 years, a little over 10 years of that working with SQL Server. Majority of that, as I mentioned, as a DBA. This past July, I was honored to be awarded the Microsoft MVP title. And right after that, I just, the way I am is I'm just like as my wife says, I just kind of have these blinders on, and I gotta just keep moving forward. As I was studying and learning about big data clusters, I had to figure out more about the underlying technology, and as a result, I went down the path of Kubernetes. Now, if you have not heard of Kubernetes, you will by the time this session is over. But they have 2 main certifications: the Certified Kubernetes Application Developer and the Administrator. And I knocked both of those out, thank goodness. And just for the sole sake of understanding the technology that makes big data clusters happen. Last year, I was honored to be part of the IDERA ACE class, 2019. And again, online, mohammaddarab.com. And if you're on Twitter, feel free to reach out at MW I did mention to Kevin behind the scenes that if you have any questions or any comments or whatever, feel free to just ask. And Kevin will interrupt me, and we'll talk about them. If I don't know them, I will reach out to the appropriate people that know, and I'll get back to you with a solid answer. So that being said, let's talk about the agenda. And I have spoken at a few SQL Saturdays, not by any stretch of the, and you talk about comparison to how many Kevin has spoken at, but we have come across a couple SQL Saturdays where I bumped into him, or he was after me, I was before him. And I personally like to do a lot of storytelling and sharing my experiences with you all. So I will pepper stories throughout these agenda points here, like the history, what is a BDC, architecture, and things like that. You probably already got your eyes at the end, and that's a surprise. I will mention a surprise at the end, and hopefully you stick around until then, and you'll have to just wait and see. So let's start with the history real quick. So if you are worked with SQL Server, you probably are familiar. If you've also been working with SQL Server for a while, that back in 2016, they came out with a feature called Polybase. I remember in 2015, I went to a Microsoft, a user group that was held at the Microsoft headquarters. I guess they call it headquarters, but it's one of their offices in Reston, Virginia. And I went there, and there was a SQL Server PFE, or Premier Field Engineer, and they were talking about the new features in SQL Server 2016, and one of them was Polybase, which you see right here. And I remember sitting there, it was mid-2015 or towards the end of 2015, and back then, I was working on servers that were running SQL Server 2005, 2008. 2008 R2 was kind of newish in my realm, and I'm working in the DC area, so a lot of my work has been with government contractors and government clients. So they're at a snail's pace when it comes to adopting the newest and the latest and greatest. So I was listening to this talk, and okay, so you can sit from a SQL Server using regular T-SQL and connect to a Polybase connected source like HDFS at the time, or Hadoop, Cloudera, Hortonworks, and bring back your big data and join it with your relational data. You don't have to learn a different language or anything like that. All of that is translation is done in the background using this Polybase feature. So that's pretty cool. I picked up on it. I understood it conceptually, but it didn't really involve me. I'm still working with 2005 and 2008, but I understood it. So moved on, and time went on, and then I were moving to 2017. And I remember when I first heard that now SQL Server is supported on Linux. And the only question I had at the time, quite frankly, was why? Why would anybody run SQL Server on Linux? It's been running on Windows, and what's wrong with that? And I really didn't understand what is Microsoft trying to do. And as a result of being able to run SQL Server on Linux, you can actually instantiate an instance of SQL Server running on a container running on Linux. And we'll talk about that. If you're not familiar with what a container is, don't worry about that. We'll talk about that in a couple more slides. But just understand that you can not only, in 2017, run SQL Server on Linux, but you can also run it on a container running on Linux. So that's cool and all, but big question of why, and then we move on. So last year, SQL Server 2019 was introduced, and they had this thing called Enhanced Polybase. Now, what does that mean, right? Well, what does Enhanced Polybase? The original Polybase was you connect from your SQL Server. You can connect to Hortonworks, a Hadoop source, and just download it, do some aggregation, do some joins, and you're good to go. Now, what is this Enhanced Polybase? If you pay attention to this image right here, let me actually bring in the mouse here. So we had the Cloudera and Hortonworks starting from the right-hand side. They integrated the Spark engine into Polybase. You can connect to a Spark engine. Now also moving over to the left, the relational databases. Not only can you connect to a different SQL Server using Polybase, different database, Teradata and Oracle. So I remember when I first figured that out and laid eyes on, you can sit from a SQL Server, and using SQL Server 2019 in this Enhanced Polybase, you can query an Oracle server, create an external table to it. You can do a select from it, bring it back, and you don't even have to learn any different type of syntactical differences when you're running. It's all done in under the hood, so to speak. That really opened my eyes a little bit, but at the same time, I was like, okay, that's cool, but didn't understand the big picture. And then you can also connect to NoSQL, Azure Cosmos DB, MongoDB, and then your ODBC connections. So now when they say hindsight 2020, at the time when I actually saw this, like, oh, that's so cool. You can actually sit from SQL Server and connect to Oracle, Teradata. That's cool. But at the same time, it was kind of like that why was, that big question mark, okay, well, what are they doing? What's the end goal with this? As a result, you can also, in 2019, deploy an availability group on Linux running on Kubernetes. So if all that is, if you are familiar with availability groups, the same concept and how things work similarly applies, but it running on the Kubernetes background, and we'll talk about what Kubernetes is in a couple more slides. So this was pretty cool, but now let's start getting into, what is what's the point of all of this? One thing I do want to clear up is whenever I do give this talk, people do ask, and I actually put this in the slide, not only in case you have this question, but if you were to download the slide deck, you have it there for you as notes. But the difference between Polybase and link servers is instance-wise scoped or server scoped, and Polybase is database scoped, more intended for analytic queries, processing large number of rows. Link servers, OLTP queries, few rows back and forth. I personally, whenever I can see the attendees, I ask how many people are familiar or have worked with link servers. A lot of hands go up because it's been around forever. And if you've worked with SQL Server, you've probably come across an environment where there's some link server hanging around someplace. And then I ask the same question. I ask how many people like working with link servers, and almost all the hands go down. In fact, I worked a couple hours today just trying to figure out a link server issue. I don't really like it. But yeah, that's the difference between Polybase and link servers for you. And now let's get into the technology that is called containers, or the container technology. So very briefly, and I want to touch on this slide, there are other sources that I will mention at the end of this that you can kind of go a little bit deeper in if you so choose, which I hope by the end of this session you do choose. But a container, just think of it as a logical unit of everything an application or service needs, all the files and everything that it needs to run successfully, and doesn't need anything else. So for example, if you are running an instance of SQL Server, now you have this image file that has everything built in this image, all the different layers and all the different files needed to be able to successfully run this instance of SQL Server is in this image file. And now, if you notice from the image on the right, that source is Docker, so docker.com. Now, you probably have heard of Docker containers. Now, Docker is the name of a company. And now what they have done, and they probably are either first to market, or the way that they have developed their Docker container runtime engine is massively adopted by the industry. So it has kind of become synonymous. Saying Docker or Docker container is similar to saying a Kleenex tissue. If you say, give me a Kleenex, I'm going to give you the company? Or you mean a tissue. So it's similar because they have massive market share. There are other companies that do provide a container technology, but Docker is the one that is the biggest, and that's also the one that is underlying technology under big data clusters and things like that. But a container, real simply, is you would download the container runtime engine from Docker. You go to docker.com, you download it for your Linux machine, your Windows machine, your Mac. They have different runtimes for different OSs, and you run it. Now it's a service running on your host, let's say a Linux machine. And now if you want to create a container running an instance of SQL Server and allow, let's say, an application developer or database developer or anybody to connect to that instance, all you do is run a command, a Docker command, and it'll download the image file from a public repository. If the image has not already been downloaded before, if it's the very first time, it'll download the image. And within a matter of seconds, you have an instance of SQL Server up. You can take that endpoint and give it to whomever needs it, and they put it into SSMS or ADS or connection string or whatever they want to connect, and they can log right in. And whenever they're done testing an application or whatever, you can delete it very quick. So once you actually have the longest time it takes to instantiate a container, especially with SQL Server, is downloading the image file. That's it. Once you have the image file and you instantiate another instance of SQL Server, it uses the same image. You don't have to download it again. It's almost instantaneously. So that's the beauty about containers, very lightweight. You can delete them, pop them back up, and very, very quick. So that makes it very easy and I guess you can say applicable to an environment where there's a lot of how do you say, continuous development integration, right? Where the DevOps, where they need to deploy something real quick, test it, destroy it, and don't really care about it. That's where this container technology comes into play. Now, the drawback, or I wouldn't say the drawback, but the issue that comes to play is when you want to be able to take the container and it has its resources, it has a memory, it has a CPU, it has network, it has all that. But what if you want to scale it? What if you want to, if a container was to die or to get corrupted, you want to automatically create another one. Or if there's a lot of stress coming in, a lot of a CPU pressure or memory pressure, you want to be able to scale a couple more containers and be able to handle that load. How do you do that? Now that orchestration and the scaling is where Kubernetes comes into play. Now, for lack of a better term, Kubernetes is a container orchestrator, quote unquote. And I guess in terms of the nomenclature, that's probably the best thing to say. It's orchestrator. It directs what things need to do what. Now, I usually like to think of a conductor in a symphony, and you see you have your percussions and you have your string instruments, etc. And with just a swing of a little, I don't even know what they call a stick. I know they don't call it a stick. And you just swing, and then the percussionists know they gotta drum a little harder, or the string instrument gotta go a little harder, different notes, and all that is done by this conductor, or in this case, this orchestrator. So Kubernetes is a beast, originally developed by Google as a different project under a different name, but a couple of people working there said, hey, let's create something that we can make open source and just kind of take it from there. And that's where Kubernetes comes into play. So it can scale container deployment. Let's talk a little bit more about Kubernetes in terms of when people say Kubernetes, what are they talking about? When they mention Kubernetes, they're talking about a Kubernetes cluster. So you have to create this Kubernetes cluster. And if you look at the image right there, in the middle, you have your master node. That's like the brains, the controller of the Kubernetes cluster. And all the worker nodes, all they do is take direction from the master. And you have these nodes, and these nodes are machines. It can be VMs or physical machines. And the master node, again, in charge of everything. And the rest are just worker nodes. So whenever somebody says, Kubernetes, Kubernetes within the context of a cluster, that's where the real benefit of Kubernetes is having this controlled. I mean, I've built a handful of Kubernetes clusters, working with big data clusters here and there, and it just, even when I was studying for the exams, the Kubernetes exam, there's no multiple choice for these exams. You actually have to do scenarios, 18 or 23 different scenarios. You got 2 to 3 hours, go. And there's multiple steps, and it was very nerve-wracking, especially with me, someone like myself. I get very, my anxiety, I can't sleep the night before, Everybody's saying, make sure you get a good night's sleep. Doesn't apply to me. I just can't do it. But it's within the context of a cluster, and it's just absolutely a beast to learn, and also the ability. And I'll say this before I move on to the next slide. If anybody's thinking about taking these Kubernetes certifications and eventually going down that route, one thing I will say is you can get certified and still, and I'm certified in both of those, and still need to review and learn. There's a massive amount of information out there on Kubernetes and the things that it can do. Very, very deep technology. So now, 2 concepts I want to make sure that we understand here. Number 1 is a node. So we have different nodes in the Kubernetes cluster. That node can, like I said, either be a physical machine or a virtual machine. So if you wanted to create a physical machine, you would need a bunch of physical machines. If you want to, 5 nodes, 6 nodes, 8, 9, whatever node. Question?
No questions so far.
Okay. I just heard maybe it was some feedback. But ideally, you want to do it in a virtual setting. Have virtual machines. And that's what I do. I have a server that I purchased off of eBay, and I just downloaded vSphere, install it. I got Linux machines, Ubuntu running, and then I can play around with that. So those are the nodes. Now, a pod, and this is very important, the pod concept is the smallest unit or logical unit that Kubernetes has or deals with. So if you have a container, we were talking about a Docker container, right? If you have your SQL Server image and you instantiate that into a instance of SQL Server running, that's called a container. That container is a running image. Now, how does Kubernetes communicate? Kubernetes doesn't directly communicate with the container per se. It wraps the container in this thing called a pod. And then through the pod, it controls the container. Now, if that doesn't make sense or it's kind of a little bit like, what? Don't worry. Even for me, I got to slow down and say it because it trips me up sometimes. This next image I created, and I honestly, I created it for myself because I was confused whenever I would say, a pod runs on a node and a node can run one or more pods. And people's eyes would kind of go crisscross, especially mine. So I created this image to hopefully shed light on that. And I am not that great at naming, so I was like, what am I going to call this? The flow, right? And, you know, that's my naming scheme there for you. So let's start from the left-hand side. You see the image file. So this image, let's say, is a SQL Server image that Microsoft has on the public repository. So we run the Docker command, and it downloads that image, and it instantiates it, and now you have a container. And I have the shipping dock containers, because that's just what I think of whenever I think of a container. And it becomes this self-confined, self-sufficient, everything it has to run, it has inside that container. Now, all the blue outlined objects you see there are where Kubernetes comes in the cluster. So what Kubernetes does is it takes those containers and it'll wrap them up in something called a pod, like we mentioned, so it can then distribute those pods on those worker nodes. Let me bring the mouse into play here. So you got these different containers running in this pod. Now Kubernetes will take that pod and based on some algorithm and what type of how much CPU or memory, etc., is on these nodes, it'll distribute those pods accordingly to the worker nodes. And then that worker node, you join into the cluster and you have the master node there. You can run containers and all that in the master node. You can literally have a single node cluster, but for the sake of it being a production and for this discussion, we have that separate. Master node is separate. Now, two things I do want to mention. First of all, I hope this sheds light in terms of the quote-unquote flow. If you have any questions, feel free to ask. But 2 points I want to make here. Number one is right here, this image to container is a one-to-one. So if I have a SQL Server image and I instantiate it now as a running container, I can't put another image in that container. So the one container has one image or one service running in it. That's it. You don't have 2 or 3 different services, let's say Apache Spark or Hadoop or SQL Server services running in one container. Those will all be individual containers, the separate services. Now, coming over to the pod, now you do see we have 3 different containers in a pod. So you can have multiple containers in a single pod. Now, when would you do that? If the pod was to die, for example, get killed for some reason, let's say the worker node decided or Kubernetes decided, hey, this pod is not responding fast enough or whatever, it'll kill the pod and recreate it. You don't care if all the services on that single pod die at once because they all kind of were interdependent. So for example, if you have SQL Server here, you have SQL Server container running in this pod, and you also have another container that's running some type of metrics collection or log collection service. And that log or metrics collection is dependent on SQL Server. So if SQL Server is not there, it's not collecting anything. So they go together in a pod, and if the pod was to die, we don't care. So and you wouldn't want, let's say, your back-end database application in there and also your front-end application on one pod. You wouldn't want that. You want to distribute them up. So hopefully that makes sense. So all of this, and we talked about Polybase, containers, SQL on Linux, and Kubernetes, and all of this kind of scaling and stuff. And The question is, why with SQL Server 2019? And when I was putting this presentation together, I came across a couple pieces of statistics that at the time, I mean, of course, I've given this talk a few times, to say the least, were really jaw-dropping. And I want to share that with you so we kind of get a understanding of of what's going on. So let's dive in. So here's the first one for you. Data never sleeps. 90% of all data today was generated in the last 2 years. Now, one thing to note is this is from a few years ago. So that 90% is probably, not even probably, it is higher, probably 91, 92%. I don't know what the number is currently. But usually when I can interact with the attendees and I can talk to them, I ask them, what do you all think is generating this 90%? What is the force behind it? What is it? And overwhelmingly, a lot of the answer is social media. Social media is generating all this data, and they're right. Just to share another statistic with you, that of a company that you all have probably heard of is Walmart, and I want you all to read that real quick. Give you a second to look at that. So Walmart collects 2.5 petabytes of data from 1 million customers every hour. They have data on over 160 million people. And these are just, I mean, what would you think this data is? Facebook messages, tweets, YouTube, Yelp. You leave a Yelp review, they will get it. And not necessarily you, but just in general, they are aggregating all this data. So if you were to use one of these platforms, then most likely your information is in their servers. Now, if you're wondering, Walmart? Yes, Walmart. Not the, yes, now we're talking about the retail industry. We're only talking about one company in the retail industry. We're not talking about Amazon or Target or any other industry like agriculture, healthcare, anything like that. We're just talking about the retail industry. 2.5 petabytes every hour from 1 million customers. Now, Walmart has a different, I guess you call it branch or subsidiary called Walmart Labs. Now, you all have probably heard of this, Walmart Labs. And if you want to get an idea of what Walmart Labs does, just go to any job board site and type in Walmart Lab, or even go to your Google or Bing and type in Walmart Labs jobs. And you'll see the majority are data scientists, data analysts, these PhDs, and these individuals. So Walmart Labs has this processing capability, this data center that's pretty much used to analyze and figure out what's going on. And just to share a little story, and this is true, I just didn't want to overload the presentation, but very quickly, they found out that Walmart found out that during certain period in Florida, sales of strawberry Pop-Tarts would spike 7x, 7 times. And they started to get curious, what's going on here? And they started to do, the cross examination and aggregation, this and that. And they found out that during a hurricane in Florida, sales of Pop-Tarts, people would just go buy Pop-Tarts, strawberry Pop-Tarts. And the sale would spike 7x. And they found that out through all of these, storing this data and then analyzing it and going through it. So now what do? Every time there's a hurricane season or hurricane week, they push strawberry Pop-Tarts front and center to maximize that. So it really comes down to not only grabbing all the data and analyzing it, and then maximizing profits and minimizing loss. Most recently, you all probably come across this in the news. TikTok. I personally don't have TikTok, but who doesn't, right? A lot of people have TikTok, and in the news they were saying, oh, Microsoft is going to purchase TikTok. I guess the US subsidiary of TikTok, so there's no issues, this and that. And then they fell through, and then Oracle came in, but Walmart was also part of that. And it was interesting because when I saw Walmart, like ding, 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 it's Walmart Labs. Because I think the biggest demographic for TikTok is between ages of like 14 and like young 20, 22, something like that. And over 800 million people, massive data generation. and they want to dive into that data. And that's why they were going for it. When I saw Walmart going for it, I was like, very, very interesting. That I've been talking about Walmart Labs and all this and that, and now they want to go for TikTok. Now, I'll leave you with this last quote from the Walmart CEO. And just one thing, this was from 2013. Give you a second to. So we want to know what every product in the world is. We want to know who every person in the world is. And we want to have the ability to connect them together in a transaction. Wow. This isn't just some CEO saying, we want to do great. This is, he wants to know who every walking person on this earth is, and every product, and just bring them together. And why do you think TikTok is such a hot commodity? And I like to joke sometimes that the Walmart CEO, you can replace that with Dr. Evil, and you're like, yeah, it makes sense. Every person, every product. But yeah, that was in 2013. We're going in 2021. What do you think is happening? So all of this to give you an idea of just one sector and one retail giant, Walmart, and how much data do they collect. Now, this is where SQL Server comes in and says, hey, I used to be a relational database engine. That's all I did. And now I can actually step outside and work with these technologies with something called big data clusters. So I can actually analyze all of that aggregation if you wanted to do via Hadoop and Spark and this. It's part of me now. Now they're completely outside the box. And that's when I started thinking, oh, hindsight is 2020. So they initially did Polybase, and then they, Linux, and then enhanced Polybase, added all these connectors, and then now they come out with big data clusters. Now Azure Arc is a whole different beast. Now I start to see Microsoft really thinking outside the box. Now let's talk about what is a big data cluster. Let's start with the definition. This is taken from the Microsoft website. And again, if you were to download the slide deck, that link will take you to the documentation site. But BDCs, or big data clusters, allow you to deploy scalable clusters of SQL Server, Spark, and HDFS containers running on Kubernetes. Now, you think about those containers and the pods. Go back to that image of the flow. Right? These components are running side by side to enable you to read, write, and process big data from T-SQL or Spark, allowing you to easily combine and analyze your high-value relational data with your high-volume big data, or your relational data and your big data. Start to combine those two. Now, I'm not big with Spark, and I would like to say yet, because I'm starting to learn about that. I want to kind of dig a little bit in that. I spent the last few months going into Kubernetes. I'm trying to shift over and learn the other aspects of big data clusters. But Spark, you see how they have read and write, process big data from T-SQL or Spark. They're kind of putting it together, T-SQL and Spark. With T-SQL is language you query, SQL Server, relational data. Spark is that engine that allows you to use multiple languages like Java, R, Scala to connect to data sitting in Hadoop and HDFS, or the Hadoop distributed file system. Now, Spark is pretty much the go-to technology. It replaced MapReduce. That was, if you've probably heard, MapReduce was the original framework that they use, and language to be able to connect and download process data from Hadoop source, but it was very, very slow. Spark was revamped, in memory, allows you to also use different multiple languages to kind of go through Spark SQL, and I think now they're on Spark 3.0, if I'm not mistaken. But yeah, I'm very, very excited. I'm still learning about Spark, but the speed at which you can do things is beautiful, because that adds to the Kubernetes and the containers and the SQL Server and just makes it a lot better. If it was T-SQL and MapReduce, yeah, it probably would have been not as appetizing. So this image right here, taken from a source from Microsoft, is the overall. You look at the objects right here. Is you have the entire artificial intelligence machine learning platform end to end running on SQL Server, and that's just still. I mean, every time I say it's mind blowing. You go from a relational database engine, a SQL Server DBA, let's say like myself, who doesn't even know everything about the database engine. But now it's this. Oh my goodness. Now I have to figure out, what's going on. But you take it piece by piece, and it's just a whole different game. You have, starting from the left side, you got your unstructured data coming in, whether it's IoT devices, it's streaming, let's say, from Twitter or Facebook, whatever message, hashtags. Maybe if you're watching the presidential debates, whatever, you want to see what people are saying in hashtags or certain words. You stream that in using Spark Streaming or Kafka, stores it in HDFS within the big data cluster or your SQL Server data pools. And then you can use, that's where the Spark machine learning services and all that, the prep and train part, where they do their modeling and aggregations. And I like to say the data analysts and data scientists are smart people coming to do their work, all within the confines and context of a big data cluster. And then once that's done, you have your BI apps, Power BI, any other BI tools coming in and extracting that data and presenting it. And all of that is happening within this big data cluster. Now, this is huge in terms of not only is there a learning curve, the huge learning curve, but just to be able to set this up, deploy a big data cluster, understand if something was to happen in terms of you need to troubleshoot, where to kind of go and where to troubleshoot and kind of get a little bit more confident in dealing with that. It really elevates your game, elevates your position and your relevancy. And again, that's the whole point of this session, is to kind of see, don't get overwhelmed with this. I'd rather be look at it like, oh wow, there's more things to learn. So let's talk about the architecture a little bit. So big data cluster architecture. The only thing, so I took this image from the Microsoft documentation. The only thing I did to this was I bolded the black, the red, and the green, the outline. So it kind of gives a little bit of contrast. Otherwise, I was just like staring at it, like, what the hell's going on? So let's kind of look at this right here. This big green bolded rectangle here is the big data cluster, everything inside here. So your compute pool, your storage pool, your data pool, your application pool. And then your SQL Server master instance is inside, or is what is built when you deploy a big data cluster. And very quickly, your SQL Server master instance right here is the entry point of where you and I log in. So DBA, developer, some app, BI tool, whatever, they go in through this SQL Server master instance. All of these pools right here, storage pool, data pool, application pool, are in a way abstracted from your view. So when you log into a master instance, you log into SSMS or ADS, you just look at it, it looks like a regular SQL Server. You don't see the compute, there's no folder that says compute pool, so that's all abstracted from you, which is good because you would just get more confused, and it really doesn't, you don't really need to see it per se. So now one thing I want to note is this controller piece right here is actually inside, should be inside this green, but if you notice these things are kind of like it was pulled out of it. And funny thing, I reached out to Microsoft, I'm like, is there a reason why this is out of here? And they're like, yeah, we just couldn't fit it in the graphics. So it was like a graphics issue, but that's fine. I don't know. I'll probably have to see if they updated it or not, but this was from last year or something. So one thing I do want to mention here is that when you see this pool, this word pool, don't get worried about that. The pool is just a logical unit of like services. That's it. So for example, the compute pool consists of pods running the SQL compute instance. That's it. Storage pool, you got these pods running your different containers that are for the storage pool. That's it. So the storage pool pods are not going to be talking with the compute pool. That's all that means. So they say the word pool, it's just the logical unit of like services. Now, you see here your external data sources. So this is where that Polybase is coming in, the enhanced Polybase. Your IoT devices, let's say you're driving a truck or something, and you're sending these data points over, can be to the cloud, and then from the cloud and go back into your data pool if you're, wherever your big data cluster is. And then over here you see the storage, your persistent storage. We'll talk about storage in a couple more slides. Let's kind of break down each one of these pools, especially in the controller, and get you a better idea what each one of them does. So the controller, when you deploy a big data cluster, and one thing I want to say before I get in, and I'll probably say it again, is if you have not used or downloaded Azure Data Studio, I highly recommend it. I do have a video or two talking about how to deploy a big data cluster using Azure Data Studio, and there's a nice walkthrough GUI wizard that helps you go through it, and you can see the different choices, and you'll, after this session, if you go and look at it, you say, oh, okay, yeah, pool. Oh, that's what you're talking about. It'll make sense as opposed to doing it from the command line, which you can. You can do it on the command line, but for beginners, I highly recommend using the wizard. And the funny thing is, whenever I ask how many people have used Azure Data Studio, not that many hands go up. But then again, this was last year when I was asking this question in person. So if you have not, go ahead and download Azure Data Studio. It's very good. I remember the first time I downloaded it, it was like 2 years ago. It was like 80 megs, 85, 90 megs. Downloaded real quick, installed it, opened it up, closed it back out, and uninstalled it. I'm like, well, it doesn't have anything. And I went back to SSMS because SSMS has like everything. And the funny thing is that I hardly use the majority of the stuff on SSMS. But I was just used to seeing everything, and I thought, maybe this isn't ready yet. But you have to download these extensions, and those are the different pieces that you can install. But if you were just to download the regular Azure Data Studio, you can see the wizard for a new deployment, and it'll show you the big data cluster deployment. So the controller, when you deploy big data cluster, the controller is what's built first. And that pretty much takes over and starts to deploy the SQL Server instances for the other pools. And it's kind of like the brains. And I kind of think of it as like some type of robot where once the brain works, it starts to create everything else. And that's what the controller does. So if you are walking through deployment and you come across an issue at this state where the controller fails, the build fails, you have to figure out what the problem is. And because you can't skip that and continue. It's like not having a brain, but I want my arm to work, if that makes sense. So in the controller, you have a couple services. If you look over to this image right here, you have something open source, actually, by the way, called Kibana and Grafana. Now, these are amazing open source, and I started hearing about this as I was getting into big data clusters, and I kind of sometimes feel like everybody else in the world knows about this already, but I'm the last one to find out about it. But yeah, I do research on what's Grafana, what's Kibana. All they are open source tools that Microsoft has added into the big data cluster when you deploy it. So now, when you fully deploy a big data cluster and you get your endpoints spitted back out to you, where you can go in and connect, you can connect to a Kibana front end. You put it in your browser and you go to it, and it's like a Google or a Bing for searching through logs. It's amazing. And Grafana is the same. You put in the endpoint, and it's not like a Bing or Google for logs. It's for metrics collection. And you see all the different dashboards and all the different, you can create alerts, all open source, all free. So that they included that for you, and they are already pre-configured to monitor and log the big data cluster. So control continue, again, manages cluster lifecycle, bootstrap, delete, updates. If you were to update your cluster, a new CU comes out, for example, the controller is in charge of updating all the instances and all that. A managed master SQL Server instance, again, and also manages the cluster security, which we'll talk about that in a couple more slides. Also on the master instance, again, as I mentioned, the main connectivity for UNI and SSMS or any other endpoint is via the master instance. And the Scala query management logic is run on the master instance. And that is used for example, if you're going to be doing any queries and using Polybase and reaching out to, let's say, an Oracle server, and the query management will figure out, okay, this is better to be pushed down. So I don't have to worry about the compute or the resource management of that. I'll just push that down and get the results back. That logic is handled at the master instance. And also machine learning services actually run on the master instance. Well, that's probably one thing that is last on my list to learn because it's probably the most complicated, and I probably won't even get to it. But machine learning, whew, that's why I say the smart people come in and use their massive brain skills to do that. A compute pool provides computation. So if you're doing aggregation, for example, doing intermediate joins, aggregations of multiple external tables, Oracle, Teradata, MongoDB, all of that compute pool, it gets pushed on, it does it, and then it spits back the result. So the compute pool, pretty straightforward. These are pods running SQL Server compute instances, and that's all they do. Again, distributed queries specifically for Polybase. The data pool, now this is used for data persistence or caching. So you can create an external table and, for example, select data from an Oracle server, for example. Let's say you have an ETL package or job, SSIS job, and all it does is it selects data from an Oracle server or any other server for that matter, and you can store it or persist it to your data pool into your external table. And then next time you go to fetch data, you need to query that. That's already within the big data cluster. You don't have to go through the network and anything else and go to a slow Oracle server in the closet somewhere nobody has touched in 10 years or whatever. So that's the beauty about the data pool. You can store and you can cache in the data pool, so it's there for you to, if you were to re-query or query it again, it's there for you. Now the storage pool is mainly for data coming in unstructured and to be stored in HDFS. So these are pods running Spark, SQL Server on Linux, of course, and then your HDFS, your Hadoop, all side by side like the definition. And they're working very close with each other. So again, data ingestion through Spark. Storage is in HDFS Parquet format. So if I have, let's say, a 3-node, for the sake of these 3-node big data cluster, and I can choose how many, let's say, do I want the storage pods on spread out among those 3 nodes? It'll spread them out, and then if I was to ingest data, it'll spread out that data across those 3 pods on those 3 nodes just for persistency. So, and you probably wondering all this talk about storage and data. I mean, how does storage work with Kubernetes and big data clusters? Storage is very interesting with the way it works with Kubernetes. And I took this image from the Azure Kubernetes Service documentation site. All I did again was I bolded the red just so it can stand out. And with Kubernetes, the Kubernetes cluster doesn't really have a storage per se. It manages it or it deals with it. So for example, if I have at the bottom there, you see Azure Managed Disk or Azure Files, you have your premium storage, any type of storage that you have. You can have NetApp or Pure Storage, any type of storage vendor provides a Kubernetes plugin to be able to communicate with the Kubernetes cluster. Presents the mount, you mount the share or the volume to the Kubernetes cluster. But when you mount it as a persistent volume, and that tells Kubernetes that okay, this will be there, and it's hosted, you know, by let's say another vendor or anything like that. So if the pod was to die, they expect that the storage will still be available. Otherwise, if this is not known as a persistent volume, or just a regular local volume, that, like, let's say you're using the D drive or whatever, or some other local storage to the node, then if the pod or node was to reboot or get killed, then that storage is wiped out. It's temporary. It wipes. There's no persistency to that data. So the persistent volume is presented to the Kubernetes cluster as a persistent volume type, and then the node or the pod, you create a persistent volume claim. Now that claim binds in the cluster master. So let's bring in the mouse here. So the API server knows that, okay, you have a persistent volume. Let's say it's like a terabyte, 5 terabytes, whatever the amount is. And then the pod has a persistent volume claim that claims data from this persistent volume. So it will probably claim the whole 2 terabytes one, or might claim just 500 gigs, whatever. And that status is bound. So this persistent volume is bound to this, persistent volume claim is bound to this volume. And as long as this is bound to this, everything is fine, that pod has that data. and everything is fine. They can access, they can write to it, they can, you can configure how you want it to write, read, write once or read, write many. The configuration can get pretty complex, but that's the gist of it, the overview of it. And I like to, in case this is confused, I want to give you an analogy. So for example, you go to the DMV, and I recently had to renew my license actually, and it being COVID, I can just do everything online, which is pretty cool. But back in the day, like 10 years ago when I did it, I go to DMV, and this shows you how long ago I've been to the DMV. Like, I remember you would pull a ticket, and you would sit down and be like, D482 or whatever. So I don't know if they still do that. So I'll pull a ticket, I sit down, and I look at the screen, and I see, okay, where's the D? Where's the D? Oh, D001. God, okay, so I gotta wait for like 3 days until it's my turn to go up. So finally, when it's my turn, I have my ticket. I give them the ticket, and then they help me. Right? They provide that service. I give them the ticket. Imagine if I lost the ticket. They can literally be like, you gotta go back in line. I don't know if you're D365 or whatever. I don't know. So go get another ticket. Now that ticketing, that ticket is the persistent volume claim to the persistent volume. So I hope that makes sense. Yeah, if you have any questions, feel free to ask, but that is the gist of how Kubernetes storage works. And that's just the verbiage there for you. Now, in terms of endpoints, there's only 5 ways to get in to a big data cluster. So when you fully deploy big data cluster and it's there and it exists, you have your compute pool, your storage pool, all these different pools, you have your master instance, there's only 5 ways to actually view or get in terms of from the security standpoint. Now, the orange one you see here, this TDS connection right here, is your regular SQL Server connection. Your SSMS, ADS, your ODBC, your connection streams, whatever, you give them this endpoint right there. And we'll see a snapshot of how that looks. Again, starting from here, you can see you use AZ Data CLI if you wanted to get into the controller. So you can actually log into the controller using the AZ Data command line interface. You have to download it. I think if you were to if you're new to Azure Data Studio and you download it for the first time and you want to deploy a big data cluster, it'll ask you, and it won't even ask you, it'll say, you need to download these tools. And one of them is AZ Data CLI. And it'll download everything, install it, and then you can go ahead and use it. So you don't have to worry about, oh, I got to go figure out how do I install it. Just go to the Azure Data Studio and go to deploy big data cluster. It'll install Python. It'll install everything that you need. So the Knox Gateway Management Proxy, for example, the metrics, logs, dashboard that I was talking about. And then you can, again, use AZ Data, VS Code, or Azure Data Studio to get into your app proxy. So these are the only 5 entry points into your big data cluster. There's nothing else that you need to worry about in terms of security per se. Now, to give you a visual, when I deployed a big data cluster a while back, I was on my home lab or home server. When you deploy a big data cluster, it spits out this screen right here. Now, if you're to forget, let's say you deploy a big data cluster and you go eat breakfast or whatever, it's like because you're working first thing in the morning. Let's say you're eating lunch or eating a snack. You come back, you're like, oh, I forgot what the command. This is the command right here: AZ Data BDC Endpoint List O table. So it's the output is in the table, and you'll see these endpoints. If you pay attention right here, SQL Server master instance front end, that's that master instance. So you literally cut and paste that, you put in SSMS, boom, you're into SQL Server. You're in charge of a big data cluster now. You're making the big bucks. And you see Kibana, Grafana, your gateway, all the different endpoints, it produces it for you, and you can access that. This is a verbiage for what we just discussed. Again, I added the verbiage just in case you were to download the slide deck. You have something, so you're not like, oh, what the hell was he saying at that picture? And you have it there for you. Now, one thing I do want to mention is if you're wondering how I got involved in big data clusters, it's because of this next feature right here, and that is data virtualization, or this concept of data virtualization. This ability to be able to get query data from different sources and then create this quote unquote virtualized layer, this data hub for you to do whatever you want to do. And now you're probably wondering, yeah, but this is via Polybase, enhanced Polybase. And you're right. Data virtualization is Polybase, enhanced Polybase, or the SQL Server 2019 Polybase. But for me, what really kind of put me into gear was the fact that it was integrated in all these other technologies. Like now you're a SQL Server DBA, or at least I am. I got to worry about Kubernetes, Docker, containers. What is all that? Spark, all this stuff. And that really kind of, it was daunting in the beginning, and still is actually daunting when I'm looking at the Spark stuff. But it really put the fire in me to pursue this. And this started with data virtualization. That this is absolutely awesome. I felt it's like I wasn't learning a new single feature in SQL Server. I was learning a whole new thing. So that in itself was the catalyst behind me going down this path of big data clusters. As a result, of course, you have all this storage and all these the data pool, compute pool, the storage, the storage pool, and all the different streaming of data coming in. You have this ability to create this data lake in this, where so many different sources are coming in, and you're just aggregating this data, and then you have different, so to speak, silos of data, right? So whatever persona needs their data, they can just go in and do it. Whether you want to go in, I like to think of it as like the deep end, or you want to go in the shallow end, or you just want to put your feet in the water. It's all there within this confines of a big data cluster, SQL Server. And I still, as I say this, it's just mind blowing that that Microsoft has done this. Now you probably have also been thinking, I see so many SQL Server instances, like the compute pool, the storage pool. Yeah, all of that requires licensing. Now, what the heck did Microsoft do with licensing? Now, licensing, at least for me, is a very boring topic. And whenever I actually open up I'm like, oh my God, I'm about to go to sleep. So what I did was I took out, or I tried to minimize the verbosity of the content for big data clusters. So hopefully by the end of this section, you'll get a rough idea of what is going on with all of those different instances. And yes, you have to license them. So let's get started with that. BDC licensing cost. Now, if you have your master instance, obviously you have your master instance, that requires core licenses. And the price right there for the enterprise and the standard, that's the generic price you'll see in the documentation. Every company and every individual, whatever, they have different arrangement with Microsoft. This is just from the generic one for a 2-core pack. Now you must have software assurance or a subscription. Now they do have a benefit, and what that benefit is for software assurance is that if you have software assurance, you are given this quote-unquote entitlement, or a BDN entitlement, or big data node entitlement. And we'll see what that specifically means. Otherwise, it's a subscription cost of $400 a year per 2-core pack. Now let's kind of get a visual to that so you see what the hell am I talking about here. So for enterprise, BDC enterprise licensing, if you got your core licenses and you have your software assurance, you get 8 times that 4. So 8 times whatever core licensing you have for your master instance, 8 times that, you are entitled that many core licenses to distribute among your big data nodes, they call them. So for example, in this image, you have your 4 cores, and then you have your 8 times 4 because you have your enterprise license, and you got your 32 BDN cores that you're entitled. You can distribute that among your compute pool, your storage pool, whatever. And if you need more, then you just have to do the $400 a year for the 16. So that's what they came up with for the enterprise. Now for standard, if you're thinking, hey, what do they got for standard? Pretty much the same thing, but the 8x is 1x. That's it. So if you got your 4x here, you got your 4 times 1, they give you 4 cores BDN. And then you just have to subscribe to this on a yearly basis, $400 a year for 2-core, for your 44 remaining. Pretty straightforward, and I think pretty, I guess, financially appetizing or appealing if you think about it. That if you're really dealing with a massive big data cluster and you're processing large number of rows and big data and this and that, you probably aren't going to skimp out or worry about your nodes, for example, your big data nodes, in terms of your licensing cost. So Microsoft has made it very appealing financially. Now, if you are on the cloud, you just use this concept called this term license mobility. That whatever you have on your on-prem, you can just use it on the cloud. That's it, done. No more complications. So that's for the BDC on Azure. Now, speaking with I guess over the past year and a half, I guess, even two, that I've been in contact with the Microsoft product team, the BDC team, and the shift and the focus is for on-prem solution for this type of big data cluster, more on-prem. But by all means, it can be done fully on the cloud. It can be done like a hybrid solution. But this is, in terms of, from the Microsoft's point of view, is more catered towards it being a enclosed on-prem solution for companies that are very secure conscious and they have a lot of guidelines and restrictions and things like that. They can still process Spark and HDFS and SQL Server using a big data cluster. Now, as I mentioned, throughout the learning path is at least for me, it was steep and is steep. I'm still learning all the time. And I leave you with a learning path. And this is an aggregation of, again, the links and videos and books and things that I learned. Some are free online playgrounds you can go and learn, tutorials and things like that. Some are paid, like part of Pluralsight courses and things like that. You can just head on over to mohammaddarab.com/BDC. Every time I make a blog post or something, I just post it there. So there's like one place to go and look at things. Because of my focus on the Kubernetes side the past couple months and trying to knock out those exams, I've held back on actually making the videos, YouTube videos. But I have a list of those I have to start working on, and those will start to be coming down the pipeline as well. I have an Excel checklist, like I mentioned, has things about Linux containers and Kubernetes. And yeah, and I just wanted to thank everybody, but I also wanted to thank you, not just say thank you, but also you're probably wondering, when the hell is that surprise coming? So I will say this. I was honored at the beginning of this year to be asked by the authors of this book, Benjamin Weissman, MVPs, and Enrico Vandelar, to be the technical reviewer for this book. And of course, I accepted. I'm not that, dumb, I guess. I said, of course, and the second edition came out, and I'm part of that. I am looking to give this book away. I had a couple of books that was sent to me, and you just go to bit.ly/free BDC book and enter in your information. At the end of this month, I'll pick somebody randomly. I'll reach out to you, I'll email you, send me whatever address you want me to send the book to, and I will send the book to you. And it's a great book, end to end, and how to build things, how to do things, and it's good to have in the arsenal in case you get excited about big data clusters. One thing I do want to say is people that I speak to and just random blog readers that look at my BDC posts, they reach out to me and they ask, hey, you did the YouTube video, thanks, I got this issue, this problem. I go back and forth with them, and I will help them as much as I can. And then if it's something that I cannot do, I reach out, I literally reach out to the BDC team. I say, hey, how do we do this? What's going on here? Because of course I learn, and also I relay that information back over to to you, for example, if you were to reach out to me. So feel free, don't hesitate. Some people might say, hey, reach out to me, and then you email them and they never get back. I'll get back to you. I want you to leave this feeling relevant and excited and passionate to learn this stuff. Because if you just go down the path of learning Kubernetes, there is a ton of opportunities, jobs out there just for Kubernetes. Not even SQL Server. I mean, you got Azure Arc built on top of Kubernetes. Big data clusters, Kubernetes. You have VMware, IBM Red Hat. All these other technologies are building these services on top of Kubernetes. So it only prepares you for the future. So thank you very much. Thank you, everybody.
Hey, thanks so much, Mohammed.
Thank you.
If there are any questions for chat, now is a great time to drop them in. In the meantime, I'll put in a couple of links as well for additional training. Microsoft has a couple of workshops around it. One of them is put together by Buck Woody. It's Kubernetes from bare metal to SQL Server big data clusters. And the other one is a Microsoft Cloud workshop on modernizing data analytics with SQL Server 2019 that I had a chance to do some edits on. So those are both available as GitHub repos. Check those out if you want to learn a lot more in addition to the resources that Mohammed gave us.
Awesome.
So far, there have been no questions.
I don't know if that's a good thing or bad. Yeah.
Positive insight, though. Sounds like few people don't have the opportunity to get into servers of that size and scope.
Yeah, yeah. One thing I will say, if they're still listening, so same with me. I didn't know I didn't have that type of. I bought the server for it was like $400 on eBay. But you can sign up for Azure if you don't have an Azure account, or even use a different email, and you get $200 of credit. Now, one thing I will say is when I started out, I was figuring things out, so I used up the credit a little faster than I would have liked. But if you were to go to the blog post, and again, the sources that Kevin mentioned, they tell you how to do it, and you can actually make the $200 credit stretch a little bit longer, farther. So that's another thing if you wanted to do that.
Yeah, because otherwise you can burn $200 credits.
Oh yeah,
pretty fast.
Very quick. Yeah.
Looks like no questions.
Okay. Well, they can feel free to reach out to me, or if they ask you questions when I'm gone, man, just feel free to hit me up, and I'll get back to them.
Sounds great. And you can reach Mohammed on Twitter, through the blog, or send the feedback form. I'll drop a link for that into chat so that you don't even have to type. I'll just copy and paste. There we go. Thanks so much again, Mohammed. I definitely appreciate the introduction to big data clusters. Oh, are you going to share your education track for learning big data clusters?
Yes, that is in the Excel document. Like everything that I use is on that Excel. If you download that, the checklist is all there.
Cool.
Yep.
With that, if there are any other questions, I'll vamp for maybe just a few more seconds. Tell people about TriPass board elections. Just switch that screen for a moment.
Sure.
And what was the link for that Excel?
Oh, my blog /BDC. Let me stop the screen share. Let me. You want me to send it to you in the chat?
Go. Just paste it in.
Okay.
Oh, there it is. The learning path to BDC Excel checklist. So yeah, it's right on there. Second bullet point.
Yep.
And also there's a YouTube channel with a bunch of videos.
Yeah, if you want to see my handsome face, you can. Yeah, it's but yeah, I do yeah. I'm sorry. You wanted to talk about the elections coming up, the TriPass.
Oh, I've already done that.
Okay.
That was just to remind people that hey, it's still there.
Yep.
Okay, it looks like that is all the questions for tonight. Thank you once more for dropping in here, sharing some knowledge on big data clusters. Definitely appreciate it.
My pleasure.
All right, have a good evening, everybody.
Take care, everybody. Bye-bye. Take care, Kevin.
Thanks.